In this demo, we showcase how VIA AIOps knowledge-driven Agentic AI operational assistant leverages natural language processing and generative AI to streamline incident diagnosis, automate remediation, and accelerate operational workflows. We begin by selecting an active incident from the VIA AIOps Incident Action Center. The signals in the incident have been correlated using knowledge graph-based correlation, ensuring an accurate, unified, context-rich view on an individual problem. The assistant leverages knowledge-augmented analysis to immediately retrieve the incident's current status, impact, most likely root cause, and resolution. Next, based on our input intent, the Agentic AI assistant initiates diagnosis. This triggers a sequence of agentic tool executions orchestrated intelligently by the assistant. First, the assistant runs the Analyze Cell Congestion Agentic Diagnostic tool. Based on real-time telemetry and historical patterns, the diagnosis confirms that there is no cell congestion, eliminating the radio access network as a potential root cause. The assistant then proceeds with the Analyze Router Workload Diagnostic tool to check historical traffic patterns on the impacted virtual router. Based on the historical patterns of the aggregation router's performance metrics, the diagnosis identifies that the router has been consistently congested during peak hours, indicating a potential bottleneck in the transport layer. To further validate the root cause, the assistant executes the Describe Pod Diagnostic tool on the pod where the vRouter forwarding engine is deployed. This inspects the containerized workloads and reveals repeated out-of-memory kills, pointing to insufficient memory allocation as another potential issue. At this stage, the Agentic AI assistant synthesizes all findings into the self-evolving knowledge plane, ensuring continuous learning from patterns, past incidents, and topology relationships to refine its future recommendations. Based on this diagnosis, the assistant proposes an immediate remediation action to update the container memory limits. The assistant also proposes an escalation to engage the transport network planning team for permanent capacity augmentation. With user confirmation, the assistant executes the container memory limit increase, resolving the resource constraint and stabilizing the affected services. Beyond remediation, the assistant supports operational decision-making through natural language queries. For example, we ask, which team is responsible for permanent capacity augmentation? The assistant queries the knowledge base and responds with the appropriate ownership, demonstrating seamless ad hoc query capabilities grounded in enterprise knowledge. To ensure proper follow-up, we instruct the assistant to create a JIRA ticket. It automatically generates a detailed incident summary, including diagnosis steps, root cause, and actions taken. The ticket is then assigned to the network planning team for capacity forecasting improvements. This entire workflow, from detection to resolution and ticketing, is powered by tightly integrated knowledge-based agentic AI capabilities, leveraging a self-evolving knowledge plane. The assistant not only automates tasks, but enhances operator productivity through contextual awareness and intelligent decision support. In summary, this demonstrates how combining knowledge-driven agentic AI, a self-evolving knowledge plane, knowledge-augmented analysis, and knowledge graph-based correlation transforms incident management into a proactive, intelligent, and highly automated process. Finally, while not the focus of this demo, these agentic workflows are enabled by agent builder capabilities within the GenAI workbench, allowing teams to configure, extend, and evolve automation logic aligned with their operational needs.